Welcome to the SEI podcast series, a production of Carnegie Mellon University's Software Engineering Institute. The SEI is a federally funded research and development center operated by Carnegie Mellon University and sponsored by the U.S. Department of Defense. Today's podcast will be available at the SEI's website, www.sei.cmu.edu/podcasts. My name is Suzanne Miller. I'm a principal researcher here at the SEI, and today I'm very pleased to have with me Jeffrey Gennari, who is a senior member of the technical staff in CERT's Threat Analysis Division. So welcome, Jeff, and thank you very much for taking the time out of your schedule to come and talk with us. Before we get started in terms of the aspects that we're going to talk about today in terms of automated reverse engineering and some of the things that does for us, tell us a little bit about yourself, how you got to be here, and what brought you to the SEI and made you interested in this kind of work.
Well, I've been at the SEI for over a decade, and I started in the vulnerability analysis world in the mid-2000s, studying software vulnerabilities and why they occurred, how to remedy them. That led me down a path to studying software flaws, software security flaws, which got me into secure coding, and eventually wound me into reverse engineering and looking at disassembly. A lot of times we didn't have source code. And when you're doing reverse engineering, you kind of naturally head into the malware analysis domain. Malware almost never has source code, at least in the artifacts that we find. And so that's kind of how I started on this path. I did reverse engineering for about 5 or 6 years and got incredibly frustrated with doing it by hand all the time. So got on board with a team that was working in automated reverse engineering, which leads us to this project.
So the SEI has done work in reverse engineering in the past. A lot of it's been focused on source code analysis, and that leads you into architecture and other things. But you're working with the binaries. You're automating the reverse engineering against the binaries. What's different about today's world and, say, 10 years ago when you started working with vulnerabilities that allows us to even think about automating this process?
Well, a lot of the supporting tools that we use and supporting infrastructure has matured a bit. We work off a platform known as the ROSE compiler framework out of Lawrence Livermore Labs. We've extended that and developed relationships with those developers. So just a lot of that supporting technology has matured to the point where we could take advantage of it. So we bring our experience as reverse engineers and software developers to that infrastructure and are able to kind of hone it so that the problems that it can solve can be applied to binary code.
Okay. So what is it that you're looking for when you are doing this reverse engineering? What are you trying to get out of one of these reverse engineered programs?
So any number of things. We're all about program understanding. We want to make the job of the analyst a little bit easier. So in the traditional manual reverse engineering, everything was done by hand. There are tools out there like disassemblers like IDA Pro that are really good at doing some analysis, but are better at incrementally annotating, gaining insights, but it's still driven by a human. We seek to have this all done in an automated way. Save as much time as possible and get as much upfront information out of a piece of software to give to an analyst so they can go ahead and get higher level insights.
And so the insights that in particular that you're trying to enable are malware insights.
Yes.
And as you mentioned at the beginning, malware, we don't get source code for malware. So once you've actually been able to do the malware analysis, can you actually go back in and provide remedies for malware with this technique? Or is this really just the analysis part, and then you're going to need other kinds of techniques to actually be able to remedy the malware?
Remediation is best done probably on a case-by-case basis. It really depends on the piece of malware you're looking at. What we want to do is get to that point as fast as possible. So we get a piece of software, we know nothing about it. We have a battery of tools that we call Pharos that do things like recover object-oriented structures and data structures that are in the code. Those can be really difficult for analysts to find and deal with manually. We generate a lot of statistical information like hashes of functions, information about function call graphs, kind of put this all together automatically and then give that to the analyst. Or at least give them some kind of enhanced representation so they can more easily make insights. Insights really vary per individual case, but doing things like finding indicators, being able to put together program functionality, being able to find off switches or kill switches for a piece of malware, that's something that we can influence. And just generally getting them to the point where they feel comfortable explaining what the software does, which is a big part of reverse engineering, as fast as possible.
So if I was a security analyst, I would want to get my hands on those tools.
Yeah.
And is that something that the SEI is enabling, is actually getting those out to the analyst community more publicly, or is this something they have to come to the SEI to actually get that service?
We have recently released our tools on GitHub and our infrastructure on GitHub. With the infrastructure, not only can you use our tools that we are making available, but you can develop your own tools for your own analytical problems. We've also released a number of blog posts and an SEI Cyber Minute, I believe, explaining how to use our tools and some of the deeper bits of the technology that go into how they work.
And for the sake of our viewers, all of those will be listed in our transcript. We always list any blog post, any URLs and things like that for getting to those. So that's very exciting that this is now becoming available to the public. Have you gotten any feedback so far? Has it been out long enough for people to actually?
It's been out long enough. It's been out long enough for people to start using the tools. We've had a few bits of interest from various researchers in academia and in industry, but we'd always love for people to really get into the tools, try them, see if they work, break them, so we can identify shortcomings, make improvements.
Excellent. So any of our viewers are really asked to do that, to provide feedback back to you on the tools, all the feedback. I know how we are at the SEI. We consider all feedback. Doesn't mean that anything explicit will be done, but we like to see what is going on with that. So this is a big milestone, but as we start talking about remedies, that's the other side of this. So have you started doing work that would lead you in that direction?
We've just started actually a new large body of work, multi-year body of work that's going to be based on our technology in unwanted feature identification and removal. So this would be the case where you have a piece of software that does something that you don't necessarily like. It calls out to a remote host that you don't necessarily trust, or does something, has some bloatware in it that you want to get around. So this new work would help take a binary, find that feature, and go around it, so as to make the software a little bit more usable, a little bit more easier to, less risky, or have more desirable functionality. So
it wouldn't actually remove it. It would just give a path around it.
Yeah, you can imagine this would be useful in cases where there's a backdoor or a component that has a significant vulnerability that can't be fixed.
So when you get done with that, I know a bunch of people in the legacy part of the world that would love for you to figure out how to actually excise the pieces of dead code that they don't want. But we'll leave that that's for the future. We'll get the path around first. So this is exciting work. I am really glad that we are able to make this available to the world so that people that are out in the public in the security field will be able to access it. I look forward to some stories in the future of things that were avoided because of something like this. I really do think this is the kind of thing that would enable some of our infrastructure, especially, to be able to find things that they couldn't find before. And that's knowing what's out there is always the first step to remedying the things that we don't want. So I want to thank you very much for your time for telling us about this, and for your blog post. That's where people will get a lot more detail about these tools, and I'm sure there's descriptions of each of the individual tools out there. So all that is going to help people to use this. So thank you very much.
Thank you.
So this podcast is available, as I said, at the SEI's website, www.sei.cmu.edu/podcast. It's also available on our YouTube channel. And I want to thank you for joining us today. As always, if you have any questions, please don't hesitate to contact us at info@sei.cmu.edu. Thank you.